So things to know is that SNS and SQS are adjunctive services that add like abstraction basically to your application communication. In other words, they can create scalability and high availability by acting as intermediaries for either duplicating messages, which is what SNS can do, or for queuing messages, which is what SQS can do. So we're going to talk about in general about why to use a queuing service. Just know also that in addition to the proprietary SQS, which is really awesome, completely serverless, they also have Amazon MQ, which is basically an active MQ. And I think now they have Rabbit MQ emulator. Like it basically will run those. They're not as scalable. They're a little bit more expensive. But if you need industry standard like AMP, oh my God, AMQP, AMPQ, I can't even remember the standard now. MQTT, kind of like the standard kind of like computing and transition protocols. Amazon MQ is good for that. And we have a lab on SQS and SNS, which by the way, I'm going to start in about 5 minutes. All right, so here's the deal. So consider a scenario where you've got a producer that is producing a message, and that message has to be processed downstream by a consumer. So the producer produces a message, notifies the consumer, and then waits for the message to be processed by the consumer. And when it's done, it's supposed to notify the producer, and then the next message gets generated and notifies the consumer and process message and da-da-da-da. This is a kind of a dependent process, because what if there's like 30 producers, there's 5 consumers, and they're all producing a message a second? That could obviously overwhelm the consumers, because maybe the consumers need some time to scale, right, as an example. Or what if the messages aren't necessarily time dependent? Like it could wait. If every message is going to take like 2 minutes to process, you could run a lesser number of consumers because you don't need it like right away in real time, right? So this is a pretty tightly coupled system. So the disadvantage here is that if like a consumer, by the way, is in the middle of processing and it goes down, also, how can you guarantee that that message gets resent? Well, you're going to have to stick it in your application logic. And by the way, if that producer is waiting for a response, that presents a whole different set of challenges of doing synchronous versus asynchronous. So this kind of synchronous process adds some disadvantage. So then if it's an asynchronous process, how would that work? Well, in this case, what would happen is that you'd put the message in a queue, put another message in the queue, put another message. You could put messages in the queue. And then what would happen is that the consumer would consume the message, process it, and then, send a notification, let somebody know, right? Like, hey, I processed the message as part of the processing. This, by the way, means you could have 100 producers and maybe 10 consumers, especially if the messages do not need to be processed in real time. Even better, if all of a sudden you get a surge in traffic, you can dump all the messages on the queue, and that gives the back end time to scale up and respond, even if it's just milliseconds of scale up, right? Plus, it breaks the synchronous link where you're tying up a producer who's now waiting for and listening for a response. So this is where the simple queuing service comes in, right? Now, the simple queuing service is a queuing service that does exactly what we described. It basically either comes in flavors of a standard queue or a first in, first out queue. Both of them, by the way, are going to guarantee that a message is going to get processed at least once. The thing about a FIFO queue, by the way, is that it's going to guarantee that it gets processed in order. So messaging order is reserved, and it's going to make sure there's no duplication. Now, I got to tell you, duplication isn't a big problem with standard queues, because you can just write to a table and say, hey, I processed this message ID, right? And then that way, if someone picks it up, you just check and see if it's been processed already. Oh, look, message ID 236 has been processed. Drop the message, go pick up the next one, right? There's easy application logic to make that work. That being said, FIFO queues, if you're like, I cannot deal with duplicates, this is like duplicate sensitive, then you can, just use a FIFO queue for that. I will tell you that FIFO queues are less performant because they do perform ordering, but they are obviously important when those are your business requirements. So here with batching, you can support about 3,000 messages per second. Without batching, you can support about 300 messages per second. Just to say the standard queues, by the way, I mean, thousands and thousands, if not tens of thousands of messages per second. It's ridiculous because standard queues don't have to do the same level of tracking, right? Those are the two types of queues. Now to use these, let's say we've got EC2 instances in step one that are putting a message in the queue. And then what happens is that we've got consumers on the back end that are going to go talk to the queue and they're going to process the message. Once they've processed the message, they're going to delete the message off of the queue. Now, you might say, okay, well, this is good. So loosely coupled. It's a queuing chain pattern. That sounds nice. Asynchronous messaging sounds good. What happens if the backend's in the middle of processing a message and it crashes? What happens is that the queue is going to keep a copy of the message. And if someone doesn't come back and delete it within a certain amount of time, the message is going to become visible again. Because what happens is that when the message is read off the queue, it turns invisible for a set amount of time. You can change that time, by the way. What happens then if someone doesn't come back and delete the message, and they have to have read it in order to delete it, so no one can just randomly delete messages. You have to read it in order for it to be deleted. If no one comes back and deletes that invisible message, it becomes visible again, which means somebody else can pick it up for processing. It's a nice system. So here we've got the producer sending a message and it's going into the SQS servers. Now here's the funky thing. SQS is completely serverless. You can't even see where this message goes, but here's the awesome thing. Amazon automatically makes a triple copy of your message. So that way, if it loses one of the servers on the back end, which does happen, you won't even see it, but the message is still available. So you don't have to worry about losing your data. I've never lost anything on SQS. I've been using it since 2013. No, but notice here, by the way, the message is only on 3 out of the 8 servers. So depending on which server you talk to, you might not actually get A in order. It's a little different, by the way. If this was a FIFO queue, it forces that message to go in order. So if there was an A and a B and a C and they were all on different servers, it forces you to read the messages in order. So you have to worry about missing the ordering if you're using a FIFO queue. This looks like a standard queue. Now the message itself has, obviously things like a queue URL, it has a message body. It's got attributes inside of the message itself, which could include a lot of stuff. Just so we're clear, remember how DynamoDB, how a row could not be more than 400 kilobytes? For both SQS and SNS, which is the service we're about to talk about next, the message cannot exceed 256 kilobytes. That's it. Small message. It's probably at least a novel, though. Okay, so here, by the way, the send message operation, send message, sends the message to a specific queue. Maximum message size is 256K. You can also, by the way, do a batch request to send up to 10 messages. Instead of using send message, you use send message batch. You can also, by the way, do funky things like it used the SQS extended client library for Java to actually chain a bunch of messages together, and you can actually send up to 2 gigs of messaging. I think that only exists for Java. I don't know why it only exists for Java, but most people don't use it for that. If you need something bigger, put an S3 link inside of your message attributes. Just link to somewhere else. Link to a database or something else that has it. Okay, so that was sending a message. Let's say a consumer wants to receive a message, right? A reminder that once a message is read, it's still in the queue until it's been deleted. That way, if the consumer never comes back to delete the message becomes visible again. This guarantees at least once processing. Now, the default invisibility timeout, let's say it's called a visibility timeout. I'm sorry. Visibility timeout. It's not an invisibility timeout. It's a visibility timeout. The default time that the message stays invisible, called the visibility timeout, is 30 seconds. You can set it up to a cap of 12 hours if you want to. You can use the receive message or receive message batch if you want to, right? So just know that there's also like different types of polling that you can use. So if we go back to this example here, if you do short polling, what will happen is it'll only talk to a few servers and it'll go really fast. If you do long polling, it's going to talk to all the servers that make up the SQS queue and say, hey, by the way, do you have a message for me? Hey, all of you guys in the queue, does anybody have a message for me? That's long polling. It's going to talk to everybody in the queue and give you a much more authentic answer, but it's going to take a little bit longer. Short polling is like, hey, you in front of me, do you have a message for me? Do you have a message for me? No? Okay, well, I'm moving on. So just know that short polling may return no message when there actually are messages. Long polling, which takes longer, which is actually the preferred method, will actually always give you a message if there's one in the queue. Question for you. What's the default visibility timeout for a message that's been read? What's the default? What's the maximum you could change it to? Yeah, good. 12 hours. Good. 30 seconds is the smallest. Like, sorry, 30 seconds is the default. It's not the smallest. 30 seconds is the default. 12 hours is the max. By the way, I'm only telling you this because it shows up on the exam. Okay. So 256K max message size, 30 seconds is the default, 12 hours is the max. I am not telling you these just to like throw out random facts. I am telling you because they do show up on the exam. All right. So in order to delete a message, you have to have read a message because you get a read receipt from the reading and you have to submit. Whoops, hold on. You have to submit the receipt handle. See this receipt handle, see the parameters where it says receipt handle? You want to return the receipt handle. The receipt handle is given to you when you receive a message. Oh, it's not listed here for some reason. Anyway, when you receive a message, you get a receipt handle. It's not listed here for some reason. And so you need that receipt handle. Otherwise, you can't delete the message. Let's see, what's the point for short polling? Short polling is faster, Gerald. So instead of waiting a second or two to hold a connection open, it goes faster, right?
Yeah, but it's inaccurate because you could have messages there and then it says no.
Gerald, this is asynchronous processing. This happens in milliseconds. This is not synchronous processing. You're going to check again in a few seconds anyway, right? So this is not for like real-time, time-dependent information, right? You will eventually get it. You just may not get it on the first time you ask, right?
Okay.
Yeah. I know you're like, well, that's horrible, Michael. Yeah, it'd be horrible for financial information or if you were trying to do real-time data transfer, absolutely. But this is for asynchronous processing. You just grunted at me. I get it. It may not fit the use case you're thinking of, but yeah. Other things to know is that obviously every queue, gets an ARN. So there's an ARN, but then notice there's a web URL, just like there is for S3 buckets. There's like a URL. There's an SQS URL, right? So, and then every message gets like an identifier. Obviously the maximum ID is going to be up to 100 characters. That one you don't have to remember. No one asked you that on the exam. Every time you receive a message, you're going to receive a receipt handle for this message. The maximum length of that is like 1K. It's like 1,024 characters. To delete a message, you have to provide that receipt handle. So when you delete the message, otherwise it's not going to delete it. So FYI. Now, in addition to message operations, you also have queue operations, meaning you can obviously, create a queue, you can change sets, queue attributes, you can, get the queue URL, list the queues that you have, delete queues if you want to. So I think delay in seconds, maximum message size, you already know. By the way, maximum message size, the default is obviously 256K. You could set that lower if you wanted to. Is there a maximum queue size? No. I know that sounds weird, Austin, but it will scale to like hundreds of thousands of messages. Now, is that practical for every use case? No, there's not. But Amazon's going to let you scale that thing out, right? I mean, especially since the messages are 256K in size, so you're going to pay for what you use, obviously. The only other parameter that frequently shows up other than visibility timeout is message retention period. So on the exam, they're going to ask you questions to kind of try and catch you about the visibility timeout. By the way, this is how they're going to catch you. They're going to say things like, someone was troubleshooting application problem and it's taken a consumer an average of 45 seconds to pull a message off the queue. People are noticing that messages are not getting processed, or they're getting duplicates, as an example, and messages are getting duplicates. What can you do in order to shift that? And it's like, change the default visibility timeout to 50 seconds or 45 seconds or something like that, right? Because the visibility timeout is what determines whether a message shows back up after it's been read, right? The other parameter that shows up on the exam is the message retention period. So the message retention period, right, is the number of seconds that the SQS is going to retain a message. Now, the default is 4 days. The maximum is 14 days. So sometimes you'll get questions on the exam. Well, they'll say, hey, what's happening is that it's taking 15, 16 days to process messages, and some messages are not being processed. What do you do, like, in order to fix that? And it's like, add more consumers so messages don't take 15, 16 days to process, because the maximum value is 14 days, right? They'll do stuff like that to see if you actually know what the default values are. So the message retention period is the time that the queue will keep the message before it just deletes it. 4 days is the default, 14 days is the max. That's really the only other thing that you need to memorize, is the visibility timeout, which is 30 seconds by default, 12 hours max, or the message retention period, which is 4 days by default, 14 days max. Okay. Here's the short polling thing again, by the way. So with short polling, again, I mentioned this, is that SQS is going to sample a subset of the servers, base it on like a weighted random distribution, and it's only going to return messages from the sampled servers, right? So for example, only a subset of the servers are going to be talked to in this case. Now, this is where Amazon started, and unfortunately, since it was the default, this is what it defaults to, right? Now, if you use short polling, right, because you only got a subset of messages, notice that you don't have E in there because we missed E, right? We'll have to ask again, right? Now, long polling is the preferred method. So only because what it does is it says, let me ask all the servers. It's only slightly longer. It's not that much more time, right? But it reduces the number of empty and false responses. So, just know that when you do a receive message, a create queue, or a set queue attributes, you can set the default to long polling if you want to. So with receive message, by the way, you have to configure what's called the wait time seconds parameter. So wait time in seconds, is that even on here? I'm going to type that out actually, because probably should see that. Wait time seconds. When you do execute the receive message API call, wait time in seconds is a parameter you can set that allows you to set long polling, right? So FYI. You can also have a dead letter queue, which is if something just is not getting processed, by the way, That's the DLQ that we were looking at yesterday, and I was like, what is a DLQ? Thank you, by the way, whoever answered that. I can't remember who that was. It's a dead letter queue. I just had never seen it abbreviated like that. A DLQ, by the way, is just like any other SQS queue. Messages can be sent to it and received to it from any other queue. You can create a DLQ using, all the things, command line, API, etc. Dead letter queues allow you to route, like if your queues are having trouble processing something, they can just route it over. You can get to control the timeout, by the way, how many times is it going to try to be processed before it gets kicked over to a dead letter queue. Do note that dead letter queues absolutely must sit in the same region as the queues that you want it to service. So, not that that's not true for every other service. So you can also, by the way, do shared queues with other AWS accounts. So remember, this service predates IAM. So like S3, you can actually share SQS queues with other services. So you can also, by the way, the queue owner, by the way, is going to pay for shared access, but you can actually set it so that your queue is publicly available or available to other accounts, right? By the way, so server-side encryption is going to encrypt the body of the message, but it's not going to touch the metadata. So, yeah. You can use your own customer managed key if you want to. You can also use KMS for this. KMS is typically the preferred method. Just know that if you have encrypted messages on the queue and you have an EC2 instance that's pulled that message, in order to decrypt it, just know that that EC2 instance has to have the KMS decrypt like permission. So it has to have the ability to decrypt it. If you're a producer and you're putting encrypted messages on a queue, you have to have the decrypt and the generate data key permissions. So just know that you have to add additional permissions if you put encryption on a queue. So buffer and batch auto scaling, the simple queuing service, by the way, can actually trigger the expansion of auto scaling for EC2 instances, right? If all of a sudden the queue gets a bunch of messages. So most people don't know this, but SQS can actually trigger auto scaling directly. So if you only have 10 consumers and you need 100 because the queue got slammed all of a sudden, SQS will actually tell auto scaling to go to 100 if it needs to. Now, just notice that it says on the right-hand side, if you're going to fan out, which means you're going to duplicate a message. If you want to duplicate a message, fan out using SNS is the ideal. You wouldn't use SQS for that. Here's another example where you've got queues here, and what happens is that the auto scaling group is actually processing like both queues. But what's interesting is one is a request queue and the other is a response queue, right? Meaning that the web servers might be checking the response queue in order to reply. So this way, even you can actually still get messaging to go through the front end, but it's being done asynchronously. The web servers are just occasionally checking to see if there's a message, right? And then sending the notification. Personally, I probably wouldn't do that. I'd probably have something else like outside of the web servers handling the response, just from an architecture perspective, instead of having it go through the front end that's already receiving traffic. But that's just me. Probably microservice that and separate it out. But again, that's just me. So you could do it this way. All right, let me just do one thing while I'm here, just to make sure we don't have a wait experience with this lab. Cool. All right. Just want to make sure we have plenty of provisioning time. Okay, because we're about halfway through. Next things to know is that we're going to develop with the SNS service, okay? Before I move on, does anyone have any questions about SQS?
Well, quick question. What is this slide saying again? I didn't quite catch the slide.
Oh, let me draw it out a little bit. So users coming in, hitting a web server, let's say they're placing a product request, or maybe it's a report, either one. They're asking for something. The web server dumps the message request over here on the queue, and these instances are going to grab the request, process it, delete it, right, do the whole thing. Once they're done, then they stick a message on the response queue, which these guys are polling, and they're going to like bring the message back, and then they're going to send a message back to the consumer. That's all that was showing, is that you could use the queues to create a feedback loop between the front end and the back end.
It's kind of like the same Lambda operation that we saw yesterday, where you have this intermediary that you hand off the works, go forth and conquer, and send it back the results kind of deal.
Exactly, same thing. Just showing the loop of request and response.
Okay.
Yeah. Good. Other questions?
And you said that you would not do your operations this way? You would use this methodology?
Actually, probably what I would do is, if I was going to do this, is I'd put another box here, frankly, and I would have this box do the messaging. I wouldn't actually like get the web servers to do double duty. I know that sounds weird, but like if they're already handling front end response and traffic, I don't want them to then also be polling, because why do I need to run them through the web servers? I'm not required to do that. I could just run another system, right? That system could be the notification system. Then I could scale that independently from the web servers, because if all of a sudden I get a bunch of responses queued up because all of a sudden the producers come out, then I got to scale the web servers, not because they're interacting with customers because of latency, but because now they're handling the response process as well. I wouldn't do that. That's a business process that could be separated out from them handling front end presentation.
Okay, I see.
Yeah. Hopefully that makes sense to everybody, right? Is I wouldn't combine business processes like that. That's what microservices are for, by the way, is to separate out those things. So. Okay. So that's SQS. Let's talk about SNS. Okay, so here's the cool thing about SNS. SNS, what happens, which we're somewhat familiar with the concept of SNS because we all inadvertently get subscribed to someone's emails, right? Or we get subscribed to spam. So what happens is that someone publishes a message to a topic. That topic then goes and talks to everybody who's subscribed in all the ways they are subscribed. This is a push system, which obviously works off consent, meaning you have come and registered yourself with the topic so that when I push a message to you, you've already said, I want this message. Now, what happens is that you publish a message once and it is copied and sent one or more times. So you can choose to direct unique messages to different specific devices, meaning you can put filters on there, or you can broadcast to many devices. So think of a topic as an access point that allows a recipient or a subscriber to subscribe to the message. So notice that an endpoint could be Lambda, it could be SQS, it could be a web post, like an HTTP post, it could be email, SNS, like a text, or it could literally be a direct mobile push to a notification. So there's lots of options. SNS is super powerful in its ability to fan out and duplicate messages. Here, there's a trading system that's sending a new stock price to an SNS topic called trading stock ABCD. I've got two queues that are subscribed to this topic, and the message gets duplicated and sent to each queue. By the way, you can modify how it's sent. You can just like do pure JSON, or you can just like change it if you want to. But once it's submitted to the queue, on the back end, I've got containers or a Lambda function or EC2, which is actually doing processing of what's in the queue. And it's either doing a trade reporting system or a calculation engine. Now, remember, I could also just send the topic directly to a Lambda function, right? Because it's going to run as many Lambda functions as I need for each message that I send. So a queue could be good here if I was using virtual machines and I wanted to stack them up or whatever. I didn't want them necessarily done in real time. Didn't really matter. But note that I could actually replace SQS with Lambda here as well. This is a fan out scenario where you take one message and you fan it out or farm it out to a bunch of different endpoints. Now, SNS is going to encode the message in JSON format and add metadata. You can also just send it as a raw message as well if you don't want to send it as JSON. So by default, it's going to encode it as JSON and you're going to put the metadata in there. But you can just, again, send it raw if you want to. This might be useful if most of your subscribers are email, right? Notice there's an unsubscribe URL at the very bottom in the middle of the message body. Let's see. Here's a use case for image processing where an image comes in, it gets triggered to an SNS topic, and then it in turn duplicates that out to 3 queues, which in turn spawn Lambda functions. Now, you could send directly to the Lambda functions. Again, there might be reasons why you do this. And then what happens is that it creates 3 different versions of the image, like a thumbnail, a max size, and a min size, you know, some variation thereof. And then it then dumps it into a destination bucket. One message duplicated to many endpoints. Now, operations with SNS, for example, you can create a topic, you can subscribe to a topic, you can delete a topic. You know, you can also publish if you want to. You can also confirm subscription. There's a couple of, there's obviously other like calls in here that you can make. You can set attributes on a topic, that kind of thing. You can do message filtering. So here you got an online buyer and an e-commerce website, you know, basically gets an order placed or maybe an order canceled. And then what happens is that notice the event type equals ordered canceled, the event type equals order placed, the event type equals product page visited. Notice that depending on what that particular like value is set to, you can apply what's known as a filter policy. By the way, this is a string matching operator that will do exact, it'll do prefix, it'll do anything but this string, right? And you can also, there's also numeric comparison operators as well, like date ranges, and you know, there's all kinds of stuff. This is pub sub, right? So what this does is that if the event type equals order canceled or order placed, the filter policy will direct it to the SQS queue. If the event type is blue and it's the product page visited, it's going to go down to a Lambda function, which is then going to post for a search engine. So this allows you to route based on attributes inside the message. Because by default, a subscriber is going to receive every single message published to the topic. To receive only a subset of the message, the subscriber can apply a filter policy to the topic subscription, which says, I only want messages that have this value for the attribute. So this allows routing logic, basically. Here, by the way, they are creating the topic shopping events, and then they are subscribing to the search index. Oh, they're subscribing the Lambda actually to the subscription ARN, which is good. And then they are attributing a filter policy with the event type is product page visited. So they are basically making it so they're creating a subscription topic, they are subscribing to it with a Lambda function, and then they are setting up a filter policy for the Lambda function. Here, the message contains a bunch of things like product and buyer, and then they're They're publishing with a string value. Event type is product page visited. So when they publish this message, it's going to match the attribute value for the filter policy for product page visited. So it's going to get routed down in the blue box down below. So this is how they've set up the subscription, their subscription to the topic for that Lambda function. And then this is how they publish a message that matches the filter policy. Again, event type equals product page visited. Any questions about that? Wait, is the filter placed in the SNS or on the subscriber? So the Austin, the subscriber gets to control, like set the filter policy. So they control what they want to get messages about. Now, obviously, they need to have some options. Absolutely. Okay, cool. One more time, just to make sure. We're creating a topic called shopping events. We are creating a subscription for this Lambda function, search index, right? And it's going against this subscription. Then what happens is that we are setting some subscription attributes for our search engine subscription ARN. This guy right here. We are setting a filter policy where event type must equal product page visited. Then when we publish a message, what we're doing is we're setting a message attribute where the event type is equal to product page visited, which will match the previous filter policy. Hopefully that's clear. All right, so here's a question for you. What did I say earlier for SQS, but also for SNS, was the max message size that you could submit across the subscription, across the topic? Good, just want to make sure. All right, each notification message contains a single published message. A message cannot be deleted after it's been published. You can't recall messages, it's not Exchange. You can't actually set up delivery policies for certain types. Like email, there's a retry if the email server doesn't fail, but like once it hits an email system, you don't really know if it's getting there or not, right? But if like a web post, you can actually do retries on web posts, retries on SMSs. You can do all kinds of retries. This, by the way, the 256 max is regardless of the messaging format, right? It's 256K. You get detailed control over endpoint access, right? So notice there's a lot of options here, right? Besides email. You can grant access to users to push notifications via IAM. Note also that SNS predates IAM, so it does have resource-based policies. You can actually grant access via that to other AWS accounts. They call it an SNS policy, but it's a resource-based policy. So just FYI. Now, distinctions between the two. SQS is going to keep messages. SNS is not. Once it's published, it's gone. It does not have a copy of the message. The delivery mechanism for SQS is you go to SQS to retrieve messages. With SNS, it is pushed to you because you have subscribed to the topic. SQS is not going to duplicate messages, but SNS is going to duplicate, right? And SQS is going to hold on to the message whether someone's available or not. SNS actually does require the system to be available, although it would also do retries. Okay. Any questions about SNS or SQS before we move on? All right then. All right, last but not least is just the MQ portion. So MQ, by the way, is a managed broker service for Apache MQ. So this is active MQ. I think they added Rabbit MQ recently. I'll have to look that up. But I think I saw a release saying they added Rabbit MQ. So this, by the way, allows you to set up message brokers in the cloud. This is a little different than SQS, which is all AWS API driven, right? Because this is a kind of more of a industry standard. Because like this will support, as you can see at the bottom, like the Java messaging service, the NMS, the .NET messaging service, AMQP, Stomp, MQTT, WebSocket. Like it's going to support bigger standards, whereas SQS requires you to use basically the Amazon SDK to use. So if you need to move something to the cloud and you don't want to rewrite your application to use the SQS messaging APIs, you're using standard protocols, you can just activate this. Now, this is a little different because it's not a serverless setup. You actually have to have an active broker and a standby broker, usually configured in a redundant pair in 2 availability zones, and they communicate with each other through EFS, using basically an EFS backend. You can actually force it to use EBS if you want to. There's some restrictions around that. The challenge here, by the way, is that only one broker is active at any given time. So this is not an active setup. So if one of them fails or undergoes maintenance, the other one, ActiveMQ, is going to roll it over to the other one. It's going to take a little while, so you will see an outage as far as like it being available. Sometimes it takes up to 30 seconds to a minute. So you can either run them in single instances, or you can do an active standby. You could do a multiple active standby, but you wouldn't get replication at that point unless you did it at an application level. So, but this is multi-AZ, so it will give you availability, HA failover for 2 availability zones. Some people, by the way, will use an on-premise message producer with an on-premise MQ broker, which then replicates the messages, right, over to Amazon, like MQ, or sends the messages over to MQ for maybe to be processed by a cloud-based consumer. People have done it in different ways, where they like route it all the way through, or they try to duplicate the messages. Obviously, for the most part, for most queues, you're trying to avoid duplication. So anyway, yeah. Now, what would be the difference between using the standard SQS SNS versus MQ? Well, one, Amazon MQ is going to have all of the industry standard features that you expect from a queuing service, whereas SQS is not. You are going to pay a little bit more for those features, but with MQ, it's going to support pub sub and all of the protocols that you saw before. SQS isn't going to support that, but SQS with SNS will support things like pub sub, right? And in general, this is a completely serverless kind of setup, which is going to be remarkably like HA within a region. MQ is going to require you to manage capacity a little bit more. It's going to be a little bit more expensive. So actually, let's look that up really quick. I think it supports RabbitMQ. Yep, Amazon MQ for RabbitMQ. That's what I thought. Oh God, that was actually a while ago. So anyway, so again, ActiveMQ and RabbitMQ are both available, right? What is the difference? Just feature sets, right? If you're using RabbitMQ already and you want to migrate up to the cloud, you don't have to like rewrite your applications for the most part. Just point it towards a new endpoint. Haha, I knew it. Knowledge check. SQS is going to give you access to a message queue that can be used to store messages while waiting for a consumer to process them. Is that true? Is that what it does? Sounds pretty good, actually. With a standard SQS queue, message ordering is guaranteed. Is that true? People are like, no, that's not true. Okay. Third, you can't filter messages when subscribing to an SNS topic. You will always receive all of the messages that are published. Good. When Amazon SNS sends a message, by the way, it was false in case I didn't say that. When Amazon SNS sends a message to SQS, it encodes the message as a JSON document. Is that true or false? Does SQS encode it as a JSON document by default? So by default, by the way, it does actually do JSON. It goes to raw or XML if you specify it. Okay, good. Now, last one, Amazon MQ supports JMS, NMS, AMQP, STOMP, and MQTT and WebSocket protocols. Is that true? Does Amazon MQ support all those protocols? Yes, it does. It does indeed support all those protocols. Okay. All right, here's the deal. We're going to combine a break and a lab. So you can just take your break whenever you're ready to. You can take it now. But here's what we're going to do is we're going to do a lab. And the overview here is that you're going to set up some SNS topics, some SQS queues. You're going to develop an S publisher, and you're going to develop an SQS consumer. Okay. So the main goal here is if we go back to our lab. Oh, good. It looks like 23 labs are pre-warmed. That should be way above what everybody needs. So we should be good to go. Notice that what you're going to do is the same thing. You're going to connect to your development environment. Again, I'm going to pick on Python, right? You're going to set up your SNS topics and your SQS queues. Notice that these probably need to be spelled exactly the way they're listed here, just FYI, including capitalization and all that. And then you're going to create your topics, create your subscriptions, create the queues. It all looks pretty decent. And then what's going to happen is you are going to, wow, that's a lot actually. And then you're going to connect to the development environment. You're going to develop both your producer, which is going to kick a message onto SNS, and your consumer, which is going to consume the message off of SQS. Again, remember that you have the solutions code, obviously inside your system. And then you're going to develop the SNS publisher. Then you're going to develop the SQS consumer. And it's pretty straightforward. I don't think there's a challenge. No, there's no challenge for this one. Okay, so there's no challenge for this one. Pretty straightforward. The duration of this lab, if I remember correctly, is supposed to be 45 minutes. But let's see what it says. All right, so, yep, 45 minutes. So here's what we're going to do is we're going to add just an extra 10 minutes on for like take a break. You can take the break now. You can take the break, later. But we're going to reconvene at 11 o'clock. So I'm going to be here, obviously, but this is what we're going to do for the next hour or so. So please take a break when appropriate. But go ahead and hit start on your lab and go ahead and get cracking if you don't mind.